last lesson we learned about naming cations, which are positive ions. Notice I didn't use specific type of element to determine the name of the ion, but I used the term cations, that is, a positive charged ions. Now in this case, we're going to use the term anions, which are used to identify negative ion. So here, we're going to look at the name of an anion. So anions are basically negative charged ions. Now, how do we name the negative charged ions? There are two things that we need to do. First, we drop the ending of the element on the periodic table. Second, after we drop the ending, we add IDE to replace that ending. So how does that work? We know that the majority of the anions on the periodic table will form a negative ions because all the elements from group 5A all the way to 7A, they all gain the electron to be stable. So let's look at those elements specifically. Here I zoom in. So first is in group 5A, where nitrogen, what is the ending for nitrogen? It turned out to be OGEN. So therefore we erase that and we put IDE. The ions for nitrogen would be nitride. That is, when you have a 3-, we don't call nitrogen anymore. Formula for the ions of nitrogen, which is N3-, this is called nitride, not nitrogen. Then we go to phosphorus, which will form a P3- ion. So again, this is the formula for the ions. So what's the ending for phosphorus? It's turned out to be ORUS. And it's going to be, of course, at IDE, so we have phosphide. Then going down here, we have arsenic, which will also form a 3- charge, AS3-. And what's the ending for it? We're going to drop IC part. So therefore, we add IDE to it, and we have arsenide. Let's ignore the rest of the element down here on the bottom because they are exception to this rule. Then we go to oxygen, group 6A, which they form a 2- because they gain 2 electrons to be that way, right? To be stable. So in this case, what's the ending for oxygen? Just like nitrogen. In this case, oxygen is YGEN. So we drop that, we add IDE, and the formula for oxygen ion is 2-. So when you see O2-, you would say oxide, not oxygen. What about sulfur? The formula for sulfur ion is 2-, but we don't call it sulfur ion. We drop the ending of sulfur, which is UR, and we add that IDE. So sulfide. So the formula for sulfide is S2-. And we also ignore selenium for now. Let's go over here. Here we have fluorine in group 7A, which they will gain 1 electron to be stable. An electron are negative, so therefore we have a 1- charge. What is the formula of fluorine when it becomes an ion? Of course, it's going F1- or just F-, because we ignore the 1 all the time. So what's the ending for fluorine? It turned out is I and E. So again, we add IDE. Fluoride would be the name of the ions for fluorine. What about chlorine? The ending is also the same as fluorine, I and E, which means we have chloride. Chloride formula will look like this: Cl 1- or Cl-. Again, we sometimes ignore the 1. Then we have bromine, of course the same ending as chlorine and fluorine, and we drop that ending, we add IDE. And what's the formula for bromide, which is the ions of bromine? We have Br 1- or Br- only. And lastly, we have iodine, which is drop the same ending, so we have iodine. And what's the formula for iodine? Is basically I and 1- or just I-. What about for group AA? If we zoom out, remember this group is a stable group, and all the elements want to have the Lewis dot structure of the noble gas, which in this case, helium will look something like this, while the rest of the noble gas looks something like this. We already have a beautiful 8 valence electron, and that is the golden rule to be stable. And that's how you name negative ions on the periodic table.